To explain pulmonary ventilation, I have created this model here to represent the human lungs. Now, pulmonary ventilation is best known as a sequence of events that help air into, like so, and out of the respiratory tract. And it is the reason that there is a continuous supply of oxygen that makes its way to a person's bloodstream. Now to start, as air moves into or out of the lungs in a single respiratory cycle, it is referred to as the tidal volume. Now to understand tidal volume, it is important to understand both inhalation and exhalation. When a person inhales, the diaphragm contracts, causing it to flatten out, and external intercostal muscles assist by raising the ribs. Now, as air flows into the lungs, the air will begin to flow from an area of higher pressure to an area of lower pressure. Now, for this process to occur, the atmospheric pressure needs to be less than the intrapulmonary pressure for a person to properly inhale, which is usually around 759 millimeters of mercury. Now watch as I inhale and exhale. As I inhale, air continues to enter my lungs, and this is because the pressure inside my lungs is lower than atmospheric pressure. And because of this, air continues to enter until the volume stops increasing in my thoracic cavity. Now closely related is intrapleural pressure, and this is the pressure in the pleural cavity, and it can range anywhere from -4 to -18 millimeters of mercury, and as well has fibers that remain stretched out, which always keeps intrapleural pressure below atmospheric pressure during inhalation and exhalation. Now, Boyle's law is also important when understanding pulmonary ventilation because when a person inhales, the volume in a person's thoracic cavity increases, which causes pressure to decrease as pressure and volume are inversely related to one another. Now, when the body relaxes from inhalation, components such as the diaphragm and the ribcage go back to their original positions, and this is called elastic rebound. So sometimes during pulmonary ventilation, there's a neurotransmitter that's secreted called acetylcholine. Now acetylcholine can act as a bronchoconstrictor, and when it constricts the bronchioles, it's going to decrease your airflow and increase your airway resistance. Now this isn't always good when this happens because it's going to make it more difficult for someone to breathe. Lastly, the left and right phrenic nerves arise in the neck between C3 and C5 and serves as a form of innervation for keeping the diaphragm functioning. Now the phrenic nerves provide sensory and motor information to the diaphragm, which is crucial in the process of pulmonary ventilation. Now hopefully this process makes a little bit more sense to you in terms of pulmonary ventilation. And don't ever forget to always take good care of your lungs because we're so grateful for each breath that we get to take.